Okay, so past couple days we've been talking about just being able to read and write ordered pairs from a coordinate plane, which is just kind of just a segue into this new unit because we're dealing a lot with graphs, but not necessarily the graphs that we saw last semester, which is being able to find slope and y-intercept and all of that. We're actually talking specifically about just transformations. So there are 4 types of transformations, and we're going to spend 2 days on each, and we split this unit up just to see how well it works. But the first type is something called translation. Now you think about translation, you think language to language, but in this particular case, translation is physically taking an image or a dot or a point on a coordinate plane and sliding it. So you're thinking about movement, okay? Not rotating, not flipping, just movement. So it's sliding like a, what do you call those on the ice hockey kind of puck, okay? So movement, sliding. Now, let's talk about some vocabulary first because vocabulary is just as important as the math itself. Translations, we talk about what stays the same. And in math, the words they use for stays the same is preserves. Preserves meaning stays. So the first thing is, does anything happen to the size of anything that we just move left, right, up, down? Does anything happen to the size? Well, nothing happens to the size. So we call that preserves congruence because it stays the same size and same shape. And then you think about, does the direction of whatever I'm sliding, whether I move it left, right, up, down, does the direction of that change? Well, it doesn't because I don't flip it, I don't turn it, I just physically move it up, down, left, right. So that's called preserves orientation. So just be familiar with the vocabulary because it can be a little tricky. And sometimes that's all they ask you on a particular question. Now, let's talk about how we do this. So it's easy as counting 1, 2, 3, and you have to know your left from your right and your up from your down. So if we look at number 1 on our notes, we are going to translate this. It says 3 units up and 2 units to the right. So you physically just count that. So if I start with letter K and put my pencil on that dot, we are going to go 3 up. So 1, 2, 3, and then 2 to the right. And then where it lands is my new ordered pair. So that's why we've been practicing that the last couple of days. My new ordered pair for letter K is 5, 0. And then notice how they label letter K, which we'll talk about more. Since this was the original K, we can't label it K also, so they came up with the symbol called prime, which is the apostrophe. So anytime I call it prime, I'm talking about the new letter, the new image, okay? We're going to do the exact same thing, but we're going to do it to letter L. So if I put my pencil on L, we're going to go 3 up, 1, 2, 3, and then we're going to go 2 to the right and put a dot. So letter L changes to this location, which is 4, 1. And again, it's the new L, so we label it L prime. If I look at M, 3 up and then 2 to the right, I land my dot there, and that's the new M, which is going to be 3, 0, so M prime. And then N, 1, 2, 3 up, 2 to the right, and it's my new N, which is 4, -1, and it's labeled N prime. So look at the shape itself. Nothing happened to it other than just moving. So it preserved congruence and it preserved orientation. Let's do that again. This time with a rectangle. We're going to move 5 to the left and 4 down this time. So 5 to the left, we're going to start with letter P. So 5 left, 1, 2, 3, 4, 5. 4 down, 1, 2, 3, 4. Put a dot. So my new P, P prime, is -4, 0. Now Q, left 5, 1, 2, 3, 4, 5. 1, 2, 3, 4 down, and the new Q is -4, -2, labeled Q prime. R, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4. So the new R is -1, -2, and then the S, 1, 2, 3, 4, 5, 1, 2, 3, 4. The new S is -1, 0. So notice, again, it's the same shape. It didn't change direction. All it did was change location. So it slid. So that's why it preserved congruence and preserved orientation. Now, that's all well and good, right? They just tell you which way to go. Nothing wrong with that. But it's math class. So, of course, they're going to use what we call rules. And that's what makes this chapter really hard, is because there are a lot of rules involved. So when it comes to translation, if we think about direction, think about a coordinate plane. That's how I interpret it, okay? Anytime I move to the left or to the right, we're talking about the X direction. We'll think about which way X goes. It goes left and right. So anytime you see X plus a number, that means move to the right. Anytime you see X minus a number, that means move to the left. We'll think about which direction the Y-axis goes. If you see Y plus a number, that means go up. And if you see Y minus a number, that means go down. So instead of them verbally telling me what to do, they're going to give it to me mathematically. So let's see what that looks like. If I look at number 3 here, it says X plus 3. Well, first things first, which direction does X go? It goes left, it goes right. If it's X plus 3, that means we're going to go to the right 3. Now, which direction does Y go? Up and down. And since it's positive 4, we're going to go up 4. So it's being able to interpret it to mimic this, which we already know how to do. So you're going to put your pencil on your dot, and I'm going to go right 3, 1, 2, 3, up 4, 1, 2, 3, 4, and put my dot. So my new B point is 1, 1. So it's a combination of this, but making sure you can interpret it. So let's do that again. Again, which direction does X go? X goes left and right. Well, since this is X minus 3, that means we're going to go left 3. And which way does Y go? Well, it goes up and down. So since this is Y minus 1, we're going to go down. Now, if you ever forget this, you can use this as a template for now. So use it, but you don't get to use it on the test. So you have to know how to interpret it yourself. So put your pencil on the dot, and we're going to go left 3, 1, 2, 3, down 1, and put a dot. So my new B is -4, -3. Doing that again. X goes left and right, but since it's X minus 2, we're going to go left. Y goes up and down, but since it's plus, we're going to go up. So then we're going to go left 2, up 5, 1, 2, 3, 4, 5, and put a dot. So my new B point is 1, 2. And it gets pretty repetitive, but this is where they try to stump me. If I look at number 6, notice that X doesn't have a number next to it. That just means I don't go left, I don't go right. Well, since Y has -3, remember Y goes up and down. Since it's -3, that means we're going to go down 3. So this particular dot does not go left or right, it just goes down 3, put a dot, and there's my new ordered pair. So that's where it can be the trickiest today. So it's -3, 1. Versus this one, they put a number next to X, but they don't put a number next to Y. Well, that means that if I don't have a number next to Y, that means I don't go up and I don't go down. I just go left or right. Well, since this is X plus 4, we're going to go to the right 4. So 1, 2, 3, 4, but no up or down. So your answer is 3, 4. Pretty easy. One more. This time X plus 3, so we're going to go to the right, and then Y minus 2 means go down. So if I go right 3, down 2, and put a dot, my new ordered pair is 1, -3. My biggest thing when we do this every year is make sure you don't count the dot as a movement, okay? The dot is just your starting point. You don't start counting until you move your pencil. So just keep that in mind as you're counting which direction to go. And again, use this little cheat sheet here to help you figure out which direction to move if you're not sure about the plus or minus or the X and the Y.